Hello, everyone. Today we're going to look at another law called the Law of Disjunctive Inference. And because we see the word disjunction in this, this law does involve the word or. So let's look at the do now. Suppose that you are a detective and that you know that either Mr. Green or Mr. Brown or both are guilty of some crime. Later, you obtain evidence which shows that Mr. Green could not possibly have been involved in the crime, so he is not guilty. Then, what can we conclude? Well, it would seem that we can conclude that Mr. Brown is guilty. So, let's reason this through. Let us rewrite this situation with logical symbols. Let P represent Mr. Green is guilty. And let Q represent Mr. Brown is guilty. The information you had at first can be represented as P or Q. Mr. Green or Mr. Brown are guilty. But then we've got the additional information that Mr. Green is not guilty. So that's not P. And this additional information is connected with the word and, but that's implied because we list them vertically. So the conclusion would be Q, that Mr. Brown is guilty. Now let's go back to the investigations about Mr. Green and Mr. Brown. If Mr. Green or Mr. Brown is guilty, okay, so again, we're going back to this. So if Mr. Green or Mr. Brown are guilty, or both, of some crime, and we find out that Mr. Brown is not guilty, then the conclusion we can draw is that Mr. Green must be guilty. Okay, so we have a second part. We have Mr. Brown or Mr. Green are guilty, and we're given the fact that Mr. Brown is not guilty. Then we conclude that Mr. Green must be guilty. And this is called the Law of Disjunctive Inference. And we can prove this to be a tautology. That is to say, if we were to write these two that we wrote vertically, I'll put 1 and 2, we would prove that if we're given P or Q and not P, which is the given, then that implies Q. And in the same way, if we're given P or Q and not Q, this implies P. In fact, we can prove this in a truth table very quickly. Let's do that. So the first part, the first truth table is done here below. And so for the P, we have true, true, false, false. And statement Q could be true, false, true, false. And then a disjunction is true most of the time, false when both disjuncts are false. And when we negate P, it's just false, false, true, true. Now, when we combine these two columns with a conjunction, we know that a conjunction is true when both are true. Otherwise, the conjunction is false. And then, if this becomes the antecedent, and this is our consequent, then we know that a conditional is false when its antecedent is true and its consequent is false. But note that when the antecedent is true, the consequent is true. So this is always true. Hence, this is a tautology, which proves the first part of the law of disjunctive inference. Now, for the second part, let's build the truth table. Now we have the second part of the truth table, and the truth values for not Q would be false, true, false, true. And when we combine and with P or Q and not Q, again, this will be false, true, true, false, true, false, and false. And then finally, if this becomes our antecedent and P is our consequent, we know that the conditional is false when the antecedent is true and the consequent is false, but here the consequent is true. So therefore, this will always be true. Hence, that's a tautology, proving the second part of the law of disjunctive inference. So now let's state the law of disjunctive inference formally. So the law of disjunctive inference is a theorem, and we just did that by proving that we have a conditional that forms a tautology. And it says that if a disjunction is true, and one of its disjuncts is not true, or false, then the other disjunct must be true. And we write this symbolically by writing P or Q and not P. That means the first disjunct is not true. Therefore, and remember, whatever goes underneath this line is a conclusion, Q. We also have P or Q, and the second disjunct is not true. We can conclude the other disjunct is true. So the law of disjunctive inference has two cases. So I'm going to list a pair of statements, and I'd like you to write down the conclusion that can be inferred, if possible, using the law of disjunctive inference. And if there is no conclusion, then write no conclusion. And here they are. So here are 4 pairs of statements, and determine what can be concluded using the law of disjunctive inference. Now, for number 3, we're given R, and then we're given not R or T. And again, whatever is above the line, we assume is true. So can we conclude a statement using the law of disjunctive inference? Well, let's see. This statement here is the negation of not R. So these two have opposite truth values, these two here. And because they have opposite truth values, by the law of disjunctive inference, we negated one of the disjuncts, so therefore we can conclude T. Now, in the fourth one, we can use the law of disjunctive inference. We're just negating the first disjunct, so our conclusion is C. But in the fifth one, we're not negating a disjunct, so there's no conclusion. In the last one, we are negating the first disjunct, so the remaining disjunct must be true, which happens to be a conjunction, R and not S. And those would be the answers for those problems. Now, let's review all of our laws before we take a look at a logic proof. Okay, so I've listed the logic laws that we use most often in our proofs. So let's go over them to make sure we're familiar with them. We've got the law of double negation, right? This is the law of double negation, which means that if we negate P twice, our conclusion is P. The law of the contrapositive says that a conditional is logically equivalent to its contrapositive. Oh, I forgot to negate this. My mistake. Let me just write that again. Not P. Okay, De Morgan's laws says that when we negate a conjunction, it becomes the disjunction of the negation of each conjunct, and similarly for the negation of a disjunction. And finally, the law of detachment was our last lesson. If a conditional is true and its antecedent is true, then the consequent is true. And that's only if the antecedent is true. And then we mentioned very quickly last time another law, the law of simplification, which is really the axiom for when a conjunction is true. And I'm going to call it the law of simplification. And it says that if a conjunction is true, then each conjunct must be true. So if we need to separate a conjunct or any part, it must be in a conjunction. If a conjunction is true, then both conjuncts must be true. That's when a conjunction can be true. Okay, now let's take a look at a logic proof. Okay, so we'll start with an easy one and we'll slowly work on to the more difficult ones. So we're given a conjunction, not P and R is true. We're given that the disjunction P or T is true, and we want to prove that T must be true. Now, of course, we can prove this to be a tautology. Whatever the given is, that becomes the antecedent connected with and. So these are the two givens. Here is the and that connects them. And this forms the antecedent. So this is the given. Then T must be true. So this is the conclusion, what we want to prove. And if we can show that this is a tautology, then that would be fine. Except that we've got P, T, and R. We've got three simple statements. We would have 8 rows in our truth table. It's so much easier using our laws to prove this. So let's try it. So we'll start with our statements and reasons. Okay. Now, we want to prove T, and a good way to do this is to work backwards. So let's make a plan down here. We want T. Well, we look at the given. What statement has T in it? P or T. So to get T by itself, to use the law of disjunctive inference, we need to get not P. But in the given, we have not P and R, and by the law of simplification, we could take not P out. Or we could just write the axiom of a conjunction. So this is our proof going backwards. So now we're ready to write it. So let's write it. So first we're going to start with the given, and we're going to start with not P and R. And from this conjunction, we need the not P. And I'll say law of simplification from step 1. Then we'll put down P or T, and that's given. And then we conclude T, law of disjunctive inference from steps 2 and 3. And again, in order to justify the law of disjunctive inference and the law of detachment, we need 2 statements. So we have to look at statements 2 and 3, where we have a disjunction that's true and one of its disjuncts is the opposite. Okay, and remember, whatever goes in the statement column is always true. All right, that wasn't such a bad proof. Let's try another one. Okay, so here we're given L or M, and then we're given not L or Q, and we're given not M. So we have 3 givens this time, and we want to show that we can get Q. And again, we can use a truth table where we can show that this is a tautology, L or M, and not L or Q, and not M, and this is a huge antecedent, then Q would be a tautology. Again, very, very complicated truth table, but the laws make it so much easier for us. So let's try to work backwards here and make an outline. Okay, so our outline. Okay, so we'll start with what we want. We want Q. Now, we look for the statement with Q, and the only one that we have is not L or Q. And in order to apply the law of disjunctive inference here, we've got to negate this disjunct to get Q out. So we need the negation of this disjunct, which is logically equivalent to L by the law of double negation. Okay, but I'm not going to write all that down. Okay, now, so we need L. Now, we have L or M, but with L and L or M, I mean, there's nothing we can do. But we also have, we're kind of stuck, but we have not M. So using these 2 statements by the law of disjunctive inference, since we're negating the second statement, the second disjunct, we conclude L. So now that we have the L that we need, we could get the Q out and conclude our result. So let's write out the proof. So we begin with statements and reasons. And because we planned it out, we could sequence it in any order we want, but as long as we write down our given. So let's see. We're going to start with the last 2 statements, L or M and not M. Those 2 are given. Given and given. And we said that immediately we can say L must be true because of the law of disjunctive inference. And remember, the law of disjunctive inference only works for a disjunction. And that's statements 1 and 2. And this law requires 2 statements to make a conclusion. Okay, now the L was needed. We're going to double negate the L, saying that it's the law of double negation And the law of double negation applies to only one statement, and that's 3, that L is logically equivalent to not L. And then we can write the given not L or Q, and that is given. And finally, number 6, then Q must be true. And this is the law of disjunctive inference. And remember what the law of disjunctive inference says, that if a disjunction is true, this is true, and one of its disjuncts is negated, which is here, then the other disjunct must be true. So this is steps 4 and 5. And notice a lot of students skip this step, but in order to get L, we have to show that L is logically equivalent to the double negation of L. So we clearly show the reader that we're negating one of the disjuncts in the given disjunction to use the law of disjunctive inference. This would be a thorough proof. Okay, let's try another one. Okay, so number 9, here we're given either Tom is a jogger or he eats green salad. We're also given if Tom eats green salad, then he is not a fool. And we're given that Tom is not a jogger. And we would like to prove that Tom is not a fool. So we're going to let J be Tom is a jogger. And let G represent Tom eats green salad. And F represents Tom is a fool. Okay, and notice that when we pick the letters to represent each simple statement, it's always in the affirmative case. So if we were to translate the given, we would have the following. Either Tom is a jogger, either or, it's a disjunction. So Tom is a jogger or he eats green salad, J or G. If Tom eats green salad, then he is not a fool. That's a conditional. So if he eats green salad, then he's not a fool. So we negate F. And we know that Tom is not a jogger, not J. And here we want to show or prove not F, that Tom is not a fool. Okay, so let's make an outline of this and work backwards, see where it takes us. We start with not F. We want not F. So we look at the statement that has an F, and that's, we have if G then not F. So since this is a conditional and I want the consequent, we'll use the law of detachment. To use the law of detachment, we need G for the law of detachment. Okay, so now let's see, how can we get G? Well, the one that one statement we have is J or G, right? And in order to get G, we need not J for the law of disjunctive inference. And we have not J in the given. So working backwards, we could get to F, to not F. So let's write this out. Statements and reasons. And working backwards, I'm going to start with the not J, which is given. And we were going to use that with J or G. That's also given. So from these two, we use the law of disjunctive inference and conclude G. Law of disjunctive. And again, the words are very important. If a disjunction is true, so you have to have a disjunction in your statement, and one of its disjuncts is not true, the opposite truth value, then we conclude the remaining disjunct. So this is steps 1 and 2. Now that we wanted G, we wanted to put that with the conditional if G then not F, which is given. And by the law of detachment, if a conditional is true and its antecedent is true, then the consequent is true. And this is the law of detachment. Steps 3 and 4. Okay, so remember, the law of disjunctive inference needs two statements written in the given, a disjunction and one of its disjuncts negated. The law of detachment needs two statements, a conditional and its antecedent, to conclude the consequent. And that takes care of our proof. So the last one has 4 given statements. We're given if A then not C, and A or W, and if R then not W and C. And we want to prove not R. All right, let's make an outline together. So again, we have to practice writing out proofs in order to be able to write them out ourselves. So the first few I will do with you so you can see how it works. So the outline. We want not R. And we have if R then not W. To get not R into the picture, we can find the contrapositive of this, which would be the negation of W, if the negation of W, then not R, which is illogically equivalent to if W then not R. Okay, so at least we have a not R this way. To get not R by itself, we need a W using the law of detachment. So how can we get that W? Well, we know that we have A or W, but that's not going to help us. In order to get W, I need not A. We do not have not A, but we do have if A, then not C. So in order to get the not A from here, we could find its contrapositive and get if not C, then not A, which is logically equivalent to if C, then not A. But notice we also have C. So with these two, using the law of detachment, we get our not A by law of detachment. So I think we've exhausted all of our given. We used all of it. So let's see how we would number this. And a good place is to start with the given. So the C was given. We'll put that first. And of course, we're going to put the second given. And we're going to write the contrapositive and the law of double negation. Okay. Then once we've got that, we conclude not A by the law of detachment. And once we get the not A, we could combine it with the disjunction to negate that disjunct, and we get W. And once we get W, we'll write down this given, its contrapositive, and the law of double negation, and use the law of detachment again and get our not R. And this would be the sequencing in our proof. So let's try to write it out. So we said we'll start with the C. And together with that, we're going to put the second given as is, if A, then not C. And we're going to write if not C, then not A. That's the law of the contrapositive. In step 2. And of course, this simplifies to if C, then not A. That's the law of double negation. In step 3. Okay. Now, the whole point was to put these two together to get not A, and that was the law of detachment. From steps 4 and 1, or 1 and 4, doesn't matter which order. And the reason why we wanted not A was so that we could put it together with this disjunction, which was given, and conclude from these two that W must be true. Law of disjunctive inference. And again, that requires 2 steps, and that's steps 6 and 7. And okay. And now that we have W, we go to this given, if R then not W, and that was given. Take the contrapositive of that. If not W, then not R. And I'll say law of the contrapositive. In step 8. And then, of course, we write down if W, then not R. Law of double negation. In step 9. And finally, now that we've got W, we can combine these two. I'll put this in green. And write down the law of detachment, not R, because a conditional is true and its antecedent is true. So law of detachment in steps 7 and 10. And that completes the proof. All right. So this takes care of our lesson on the law of disjunctive inference. And remember, the law of disjunctive inference says that if a disjunction is true and one of its disjuncts is not true, or the opposite truth value, then the other disjunct must be true. And again, the law of disjunctive inference needs 2 given statements. The law of detachment has one version, and it says if a conditional is true and its antecedent is true, then its consequent must be true. So I like this proof at the end because it combined a little bit of everything, reinforcing those 2 laws, the law of disjunctive inference and the law of detachment. All right, that takes care of our lesson for today. Have a wonderful, wonderful week. Bye.